Yes, sir.
Okay, so good morning, everybody.
Morning, sir.
Okay, so thank you for coming online. Uh,
Good morning.
okay, so last class we have studied about the T thyristor control reactor TCR, right? So today we will see about the thyristor switched capacitor, or it is normally abbreviated as TSC. Okay, so today we will see about the thyristor switched capacitor, and then last class we have studied about the TCR, thyristor controlled reactor, and how it controls the voltage and the reactive power. So we have learned. So now today we will also see another types of SBC, that is thyristor switched capacitor TSC, and then how we will control the voltage and the reactive power by using TSC. Okay, so today we will see uh, study about the thyristor switched capacitors. Okay, so first, so before we start how it controls, so first let's start with the uh, basic principle. Okay, principle of operation of thyristor switched capacitor. Okay, so it remain same like, okay, so its construction will remain same like the TCR, except here you will find, instead of reactor, you will find capacitance. Okay, so just I will explain with the, okay, so I will explain with the help of this diagram. Okay, so first I will explain with the help of this simple single phase unit diagram of TSC, thyristor switched capacitor. Okay, so it actually, so when we talk about the thyristor switched capacitor, it consists of capacitor and then switch. Okay, so that switch is known as thyristor switches. Okay, so when we talk about the TSC, it consists of a capacitor and then thyristor, so which is acting as a switch. Based on our firing angles, it will control the output, right? So, but here in TSC, there will be one additional element, inductance L, okay, which will be connected in series with the capacitor and then our thyristor switch. Okay, so whereas in TCR you will not find C, capacitor you will not find there, you will see only thyristor switch and inductance. But here you will find capacitor, switch, that is thyristor, and then inductance. Okay, so why there is extra inductance, we will see later on, but just now basic construction is it has capacitor and then switch, that switch is a thyristor. Okay, again we have a inductors connected in series. Okay, so normally this is a single phase circuit, and then how it work. Okay, so how it work is a same like a TCR. Okay, so during positive half cycle, okay, during positive half cycle, let's say T1 and T2, thyristor T1 is in the reverse bias, so T2 in the forward bias, so it will flow like this. And then during negative half cycle, so thyristor T1 will be in the forward bias and then T2 will be in the reverse bias. So this is how it flow. Okay, so this is a basic working of a TSC circuit. Okay, but we are not studying how it is controlling the voltage now. Okay, so this is a basic circuit. So now I have said that TSC consists of a capacitor, switch, and the inductors. Okay, so why there is a extra element inductors in the TSC is, so you see here third point. Okay, so in third point it has been written, this purpose of this inductance is to limit the switching transient, okay, to damp the inrush current. Basically, so if your device is capacitive in nature, so when you switch on at once, what you will have is a huge inrush of current, okay, which will damage our system or our device. So in order to prevent that, so that to prevent the inrush current when you switch on, so we are using inductors. Okay, so we are using inductors to prevent the inrush current, or we call it as switching transient. So when you switch on, so immediately you will have a high current, which is known as inrush current. To prevent that, so this inductor is connected in series with the bidirectional switch, that is a thyristor, okay, as shown in this figure A. Okay, 1A. Okay, so this is a purpose of thyristor. This is a purpose of inductor in the TSC. Okay, and then this is basically a other one is a three-phase arrangement of the TSCR. So normally TSCR or TCR will be in the delta shape. Okay, so this is just a three-phase arrangement. Okay, so three-phase means there will be three single phase unit connected in delta, and then this controller is, so we have to control the voltage, sorry, control the firing angle. Actually it is controlling the voltage only, but based on this firing angle we are controlling the voltage. To control that firing angle, so we have a controller based on the voltage. Okay, this is a basic construction of the TSC. Okay, so one is single phase, another one is three phase I have shown. So now little bit, okay, so we'll see working also we have done, but now how to choose the firing angle alpha in the TSC. Okay, so other you try to read, you will understand, but very important thing is how to choose this firing angle means switching on time and then switching off time in a TSC. Okay, so when you see about, see here, so I have given in terms of T1 and T2. Okay, so T1 and T2. So T1 is a switching on time and T2 is a switching off time. But how we will choose this switching on time and then this switching off time is very important in TSC. Okay, so now which means we are firing the thyristor, right? So now this switching on time T1 is chosen so that our bus voltage, let's assume this is a bus voltage, and then another one is a capacitor voltage across the capacitor, and first one is bus voltage, and then last one is a capacitor current through the capacitor. Okay, so now how we will choose this T1 and T2? Okay, switching time. So let's say we assume that T1 is a switching on time and T2 is a switching off time, or a switching off instant, we call it as. So now how we will choose this T1 is, okay, so it is basically we will choose this T1 so that our bus voltage should be maximum. Okay, our bus voltage should be maximum. Okay, one condition to choose the T1 or switching on instant time T1 is this bus voltage should be maximum at the same time. This first condition. Then second condition is polarity of the capacitor voltage should be same as that of bus voltage. So if your capacitor voltage is starting from here, then your polarity is not same, right? So which means we cannot choose this. Okay, so first condition to choose the T1 time is your bus voltage should be maximum. Then second one is of the same polarity as that of the capacitor voltage. So here we have assumed that capacitor voltage and then bus voltage has the same polarity. At the same time, bus voltage is maximum. Okay, why we are doing this is to ensure a transient free switching. So it means that, okay, if you choose that T1 in other way also, it will function, but what you will find is a transient switching problem will be faced. You will face this type of problem. So to avoid that, what you have to do is you have to choose such a way that T1 should, okay, T1 such that your max bus voltage should be maximum, then capacitor voltage polarity, and then bus voltage polarity should be same. Okay, so why we are doing this? A reason it has been given to ensure that transient free switchings. Okay, so then how to choose this T2 time T2? Okay, so this time T2 or switching off time instant is correspond to a current zero. So now what we have to do is, so now you try to choose the switching off time when your capacitor current is equal to zero. So why we are not choosing here? Okay, so why we are not choosing here? Why we are choosing switching time T2? If you choose here also is fine, but normally if you choose here, it's almost, okay, so even it is not a half cycle. See here, right? So we have to go for at least one cycle. So that's why we are choosing here T2. Okay, T2 equal to when the capacitor current equal to zero. So this is how we have to choose the switching time T1 and T2, which means basically we are firing on the thyristor at what angle or firing angle. So this firing angle alpha can be converted to time. You know that the relation, so which you have learned in the power electronics. Okay, so you know how to convert it into time. Okay, so but basically how we can choose is randomly. We cannot use our time T1 and T2. So T1 and T2 can be choose, or first T1 can be choose based on two conditions. First one is bus voltage should be maximum, capacitor voltage and bus voltage polarity should be same. That's how we will choose the switching on time T1, and then T2 we will choose based on the current when capacitor current is equal to zero. This is how we will choose.